So for lung volumes, I'm going to start us off with an equation. I know that they're always your favourites, right? So here's my equation for you. Get it down, make sure you understand it too, please. So we're going to say that something called minute ventilation, more of which in a few moments' time, equals, let me make sure I've got white available to me, equals, and then we're going to say tidal volume, which is going to become a really important term for us in a few moments' time. Tidal volume, again, don't worry if you don't know what it means yet. I'm going to take you all the way through it, multiplied by what I'm going to refer to as breathing rate. Okay, so I reckon you could have a real good stab in the dark at what breathing rate is, right? It's fairly straightforward. This is how many, if we were just going to sort of define it, this would be how many breaths per minute a person takes, okay? So at rest, on average, people take in the region of about 12 breaths per minute. I mean, it's something you might want to just reflect on with your own breathing, whether it's roughly in that sort of vicinity. People do differ, but give or take, you're going to breathe about once every kind of 5 seconds. That would be 12 times, something along those lines, okay? So we've got breathing, we've got number of breaths per minute. Now, what is this tidal volume thing? Well, first of all, I want you to know that we measure tidal volume in litres or millilitres. So we're going to measure it in litres or millilitres. Let me rewrite that because it looks like litres per milliliter. Litres or millilitres. And this is the amount of air going in and out of the lung, in and out of the lung per breath. Okay, so let's just reflect here. We have got the number of breaths per minute, okay, approximately 12, and we're multiplying that by the amount of air that goes in and out of the lung per breath. So per breath quantity times a minute that we breathe. Therefore, in your opinion, what must minute ventilation be? A minute ventilation is the amount of air, the volume of air going in and out of the lung per minute. Okay? It has to be, right? It absolutely has to be. And something else, the units here are measured in litres per minute. All right, so litres per minute. All good. We've got, so just to be clear here, our minute ventilation is the amount of air we're going to breathe in and we're going to breathe out in every single minute, okay? Now, that's all well and good. And we can kind of calculate this. I mean, I said to you a minute ago that we might take 12 breaths per minute. I can tell you that an average tidal volume is around about 500 millilitres or half a litre. Therefore, we can estimate that the amount of air we take in per minute is around about 6 litres at rest, okay? So that would be kind of some useful resting values there that we've just put in. About 6 litres, about 500 millilitres, and about 12 breaths per minute. Now, that's all well and good, but I want to sketch something out to you. I'm going to bring in my ruler tool. Here it is. And I'm going to draw out for you an x-axis. Let's put an x-axis in there. And I'm going to pivot this around like this, try and get that to 90 degrees. And you know what's going to come, right? You know I'm going to draw a graph. Well, sketch a graph is probably a better way of describing that. Here's my y-axis. And whenever we work with axes, we want to make absolutely sure that we have labelled these things. So on the x-axis, we are talking about time in seconds. And on the y-axis, we are talking about a quantity, of air. And we're going to measure that. We're going to measure that in millilitres. Okay, in millilitres, or maybe we measure it in litres. So, in fact, let me do it that way. Let's actually measure it in litres. That's probably more realistic. So let's do it that way. Now, I'm not going to get into how this works, but this is a trace that comes from a structure called spirometry. I mean, feel free to Google it. Go and have a look if you're interested. It's a method of measuring intake and or inhalation, exhalation of air. And the way it works is that somebody would have a mouthpiece or a mask on. They'd be breathing in and out. Maybe they're exercising. Maybe they're just sitting there. And as they're breathing in and out, their breath is moving up and down what's called a bell jar. And this bell jar is attached to a pencil. And this pencil is kind of making a line. And I'm going to show you that at rest, let me do it in pink because that was our tidal volume colour. At rest, this is what our tidal volume might look like. Okay, now those of you that are studying physics will probably look at this and say, hey James, that's a transverse wave. And it would be if we were doing physics, but what we're going to say here is that the peaks of this plot, this is our in breath. Okay, so when we breathe in, of course, the quantity of air goes up, right? So it comes to this peak. And when we breathe out these troughs, this is how much air, if I was to plot that across to here, that's the amount of air left in the lung after I breathe out. So all this is heavy breathing to you. I mean, take it in the right way. I'm trying to educate in this case. Now, that's all well and good. And we could simply say, guys, that there is our tidal volume. So I'm just going to put TV. And we know, because we know if it's tidal volume, we know that value is going to be something like 500 milliliters at rest, okay? Now, here's the interesting thing. Let me just take my eraser, and I'm just, whoa, that was not what I meant to do. I'm on the wrong, that's going to be interesting. I just realized I've drawn on the wrong layer. So this is what I'm going to do. I'm actually going to leave my kind of plot in here, but what we're going to do is we're going to imagine that this goes slightly differently. So if I was to take a very deep in-breath, of course what's going to happen here is this curve is going to continue up and then come down to here like this. So we're going to have an additional quantity there. And then what's going to happen here is that when I blow the air out, okay, there's going to be an additional quantity of air leaving my lung like this. Can you see how I've taken more in? More out. Okay, so those volumes are greater. Now, the point I would make to you is this, that this, assuming it's maximal breath, this value here is what we would refer to as your vital capacity. And it's the maximum amount of air that one can take into one's lungs and breathe out in a maximal breath. Okay, that's kind of useful. So we've got our vital capacity in there. But you should also notice that not all air actually leaves the lung, because of course this is no air at the lung here. So even in a forced out breath, some air remains in the lung, and we refer to this as the residual volume, and that's the air left in the lungs after a maximal out breath. And you might want to reflect on why we do keep some air in the lungs. And if you reflect on your knowledge of alveoli, very delicate, single cell thick, pass by those endothelial capillary cells. These are very delicate structures. So by maintaining a small amount of air in the lung, even after I pump my lungs empty, or as empty as I can, that protects those alveolar structures and prevents them from being damaged. So I just want to do a bit of a recap here. In fact, I sort of want to give a few definitions, really. I know you guys, again, love a definition. So residual volume, let's be crystal clear what we mean by this. Okay, residual volume, we're talking about the volume of air left in the lung, left in the lung after a maximal out breath. Okay, so that's our residual volume. Beautiful. Residual volume, sorry. And I just want to remind you that your vital capacity, because we've kind of already defined our tidal volume and our minute ventilation. So our vital capacity here, we've got the volume of air breathed, obviously. I mean, I don't know why I said that like that. in and out in a maximal breath. It's one of the problems with teaching like this. I'm kind of on my own in like a little studio here. And if you make yourself laugh, it's kind of tricky to stop. So anyway, there you go. There's our definitions there. And my final point is this one. We have said that obviously vital capacity is this maximal point. And the thing I'm going to say to you is, of course, as we start to exercise, what we're going to find is that our tidal volume will get bigger like this. And just remember that tidal volume can increase as a result of exercise. So of course, if tidal volume increases, it means we are breathing more deeply. You know that during exercise that happens. You know it happens. But also during exercise, we start to breathe faster. And therefore, during exercise, what happens to our minute ventilation, the amount of air breathed in per minute? It goes up by definition. Now, the one thing I'll just say to you is that your breathing depth goes up first. See if you notice this next time you exercise. And your breathing rate increases second. In another level, perhaps when you're studying beyond this level, we'll talk about how that happens and why that is.